All right, hello. How's everybody doing? All right, we're going to talk about angle relationships. The first one is adjacent angles. Adjacent angles are basically two angles that lie on the same plane, have a common vertex and a common side, but no common interior points. All this basically means is that they share the same vertex and the side, which is one of the rays. For example, here angle ABC and CBD. Those are the two angles inside of the angle which is ABD. ABC and CBD are adjacent because they share the same side, which is CB, this right here. Now, a lot of you might have gotten confused with this one, but the only difference is it's the same picture, but they're talking about angle ABC, which is inside of angle ABD. They do share the same side, which is AB, and they do have the same vertex, which is B, but ABC is actually inside of angle ABD, so that's not considered adjacent. Adjacent, they got to be side by side to each other. That's the only real difference. Here, the only thing that the angles have in common per the definition is the vertex, but they're missing the same side, so that's why these aren't adjacent. All right, moving along. Let's talk about vertical angles. Vertical angles are two non-adjacent angles. If they're non-adjacent, that means they don't share a side, but in this case, they do share a vertex, formed by two intersecting lines. In other words, if you got two lines that make the letter X, chances are you got vertical angles. Vertical angles are opposite of each other, hence angle AEB and angle DEC are vertical. And DEA is vertical to angle BEC. Don't forget, you can name the angles different ways. I can say BEC is the same thing as angle CEB. Now, why is this not vertical? Real simple. They share the vertex, but the actual lines are intersecting, they're not making an X. That's honestly as simple as I can make it. The correct term really would be is that both angles have to have a pair of opposite rays. So in this case, these two angles here I'm pointing at, which is AED and angle BEC, they have one opposite ray. It's not even a ray, but let's just say that EB and EA, we make them rays, they'll be going in opposite directions, but the other segment, which is DE and EC, they don't do that. So that's why this picture here in particular will not have any vertical angles in it, but this one will. Like I said, you can just make the X. Linear pair is a pair of adjacent angles. Again, adjacent angles mean that they share a side and a vertex. They basically are side by side. So both these examples have examples of adjacent angles. There's only one difference though. The main difference is the word linear. When you see the word linear, you think line. When you think line, you think half a circle. When you think half a circle, you're basically saying 180 degrees. So this one for sure makes 180 degrees. This one doesn't. So that's why this one cannot have linear pair. They're adjacent. Yes, DEB and BEC are adjacent. They share vertex E inside EB. Yes, but they're not linear pair because they don't make 180 degrees together. When I say make, I mean that they add up to, just in case. So that's why this works. All right, moving along, you should have also copied for your notes complementary and supplementary. They're both easy to remember. Complementary means that they add up to 90, and supplementary means they add up to 180. You can just do the alphabetical trick. 90 comes before 80, C comes before S. That should help you out. Supplementary angles can also be linear pair, but don't forget linear pair cannot be supplementary, because supplementary means that they add up to 180 per definition, which basically says that they can either be adjacent, which means that they can be next to each other, they can share a side, or they can be separate, as you see in this picture. Same thing here with complementary angles. Angle 1 and 2 are considered adjacent because they share this side here, this ray. That's basically dividing the angle. Now dividing by 2, we can't assume that, but it is dividing it. We don't know if it's by 2 because we don't know if angle 1 is congruent to angle 2. And again, congruent means that they have the same measure. And this is another example of complementary angles. PQR is complementary to angle XYZ or ZYX. Why? Because 50 plus 40 is 90. Same thing here. These two angles are considered supplementary, even though they're not adjacent. So they can't be linear pair, but they're still supplementary because angle M and angle N add up to 180 because 100 plus 80 is 180. Here, this picture here, you have two options. You can either call this linear pair because not only are they supplementary angles because they add up to 180, but also too, they share a side and a vertex, which makes them adjacent. In other words, EFH and HFG. together, they make 180 degrees because they make half a circle or a straight angle. In this case, there's no measurement, but you can safely assume this because you know a straight angle is always 180. It's never going to change. So that's why we can assume this. We can't assume that these two angles 1 and 2 up here are congruent because we don't know. That's not always the case. It's not a constant. So in other words, we just can't assume it because we could make a mistake. Okay, moving on. Next thing is perpendicular lines. Perpendicular lines is simple. This symbol, do not forget it. When you see this symbol here, this reads line XZ is perpendicular to line WY. When you hear the word perpendicular, you always think 90 degrees. And as you can see here, technically we got 4 angles. And if you wanted to, you can say that this angle I'm pointing at is vertical to this one. And this angle to the right is vertical to this one. Why? Because they have a common vertex and their rays are opposite to each other. And you can also say they're opposite. And they have intersecting lines that make an X. Now, perpendicular is a special case. When you have a perpendicular, chances are all 4 angles are perpendicular, which means, in other words, they make 90 degrees. Let me clarify that. When the lines are perpendicular, they make right angles. And in this case, they make 4 right angles. Why? Because you got 2 intersecting lines. As it says here, perpendicular lines intersect to form congruent adjacent angles. And what do you mean by congruent? They mean the same measure. In this case, each measure is 90 degrees, as it says up here. All this can be safely assumed, only because of this symbol, which means perpendicular, which basically says when 2 lines meet, they at a perpendicular point, that means they make 90 degrees. The right angle symbol in the figure indicates that the lines are perpendicular. In other words, this symbol right here says this is 90. And think about it. If the line XZ is a half a circle or a straight angle, that means it's 180. So this is 90. Guess what? This has to be 90 as well. Why? Because 90 plus 90 is 100. Same thing here. YZ is 180 degrees. So if that's 90, this got to be 90 because 90 plus 90 is 100. And so on and so forth. So if you go all the way around, all of them have to be 90 by default. That's why this is safe to assume. If you got 2 intersecting lines, if they're perpendicular, that means they make 4 right angles at that point. All right. Now, as we were talking about, do not assume. This is good reading. Do not, while 2 lines may appear to be perpendicular in a figure, you cannot assume that it's true unless other information is given. In other words, unless they give you this symbol here, automatically that says that this ray, which is PN, is perpendicular to this other ray. They're both rays. That particular symbol means perpendicular, so that means this angle right here, which is MPN, is 90, just because they said this. These are other things you can't assume unless you have it. If you have this information, then you know for sure that OPQ, which is this angle, is congruent to LPM. If you just got this picture here and you don't got this information here, you can't assume anything as far as this is concerned. You can't assume perpendicular unless they say it. You can't assume they're congruent unless they tell you, both for angles and segments. Don't get caught with that. If you do, chances are you get it wrong on the test. What can you safely assume? All points shown are coplanar. Correct. Collinear. What's collinear mean? That means that they actually share. They're in the same line, or they share the line. They make a line, basically. Ray PN, Ray PM. Excuse me. Ray PN, Ray PO. Line LQ intersect at point what? P. That is true. All of them meet basically, or end and continue from point P. Angle LPM and angle MPN are adjacent angles. LPM's here, MPN is here. Yes, they're adjacent. Why? They share a vertex, which is P, and the same side, which is PN. So they basically are right next to each other. And you can say they overlap because they share the same side or the same ray. If they share the ray, then they have the same vertex and the side. Also, angle LPN and angle NPQ are what? Linear pair. In other words, LPN is this one. This is LPN, so we're talking from here to here, this rotation. And the other one has to be, without even looking, for me, has to be NPQ. Why? Because this angle here that I have my arrow at, to make the 180, which is this straight line, or angle, has to go all the way to here. And what is this angle here? It touches from here to here, so that has to be NPQ. And that's safe to assume that they make linear pair. Why? Because a straight angle always makes 180. And this one's safe to assume too. QPO and OPL. QPO is this angle here, this little small acute angle, and then OPL is this big obtuse angle. And when you notice these two angles here, these ones that I'm basically highlighting with the arrow, they make a straight angle. They're saying supplementary, but really and truly you can say linear pair, and that's safe to assume because again a straight angle always makes 180. And that's it for this video. This is just showing you, the terms that you're going to need.